Hey everybody, this is Structure Steve again, and in today's video I'm going to give you an overview of the ProConcrete 3D rebar modeling tools that are in OpenBridge Modeler and ProStructures. And I'll also give you an overview of the various workflows you can use to model rebar in 3D.
So the topic of rebar modeling comes up pretty often when we have these trainings or just talking around with other people, and they're curious as to know what can or cannot be done inside of OBM and kind of what the workflow is like. So we're going to give a quick overview of that and what's included in OBM, what we can do, and a quick overview also of just the high level workflows and the tools and stuff. So I'm actually going to switch to file for a different training that I do that has some rebar modeled in here, just to kind of talk from. And so this model we're getting into here, this is going to be a pier model where we have the reinforcement in the footing fully modeled, the column. We just did some of the unique bars in the column, and we also did some of the unique bars in the cap here. But let's start off by talking about what is and is not included in terms of rebar modeling tools here inside of OBM. And it was a couple versions ago where they finally included some of these rebar modeling tools inside of it. And what they did is they basically gave us access to some of the tools inside of ProConcrete. So kind of taking another step back and high level view of ProConcrete, that workflow is actually in the drop down over here under ProConcrete, and that's where you're going to see the rebar modeling tools here. Now, sometimes you hear the term ProConcrete, sometimes you hear the term ProStructures. ProStructures, you can kind of think of that as a box or a container, and inside that box you have ProConcrete and ProSteel. Now ProConcrete is the rebar modeling and detailing software that Bentley offers, and ProSteel is the steel modeling and detailing software that Bentley offers. ProSteel can be used to some degree on like steel bridges, but it's not really quite that useful there for us yet. Plus the resources aren't developed for meeting FDOT standards for it, so we're never really not going to use that at this point in time. But ProConcrete is very much useful for us in the bridge world, and we can model all the typical bridge reinforcement that we ever encounter and do our 2D planes production from them as well. So ProConcrete, what did they give us access to inside of OBM? They gave us access to about 50% of the tools, and they left the other half of them out, and they left those in the full version because they obviously want you to get the full version of ProConcrete to do something. But what they gave us access to are all the rebar modeling tools that we need to actually model the bars in 3D here. So all this rebar that you see in here, right? We can model all this reinforcement in OBM with the ProConcrete tools they gave us access to. And then the last few functions they gave us are the positioning and the manual marking here. So this is basically, we can apply bar marks to all the bar elements, and it can identify the shape based on the standard FDOT bar bending details. So now the stuff they left out of OBM, which we have to go into the full version of ProConcrete, or we have to activate a license of ProConcrete through OBM, and then you can use those full version tools actually inside of OBM. That's something that they introduced about 1 or 2 versions ago. Those tools that are left out there in the full version of ProConcrete are going to be the ones to produce the 2D drawings. So if we want to produce, let's just look at like a standard pier sheet here. If we want to produce a drawing like this, where the bars are represented by a center line of bars, some people call them like stick bars, and then bends that are into the page are represented by like a little dot like this. Anything like this, or like this pier cap here, like these kind of drawings here, these are what you would want that full version of ProConcrete to produce. And there are some pretty big benefits to doing that because ProConcrete does automate a lot of things. It actually automates the labeling of all this stuff. So if you actually cut a section through this pier cap or in front and then point towards the pier cap, it'll actually automatically re-symbolize all the 3D bars into these center line of bars here. and it will actually go ahead and apply bar labels for us. And then when the bar labels update, if we go and update some bar labels or anything like that in the model, then your annotations actually automatically update, which is pretty powerful. Bar ranges like this, like 7 spaces at 9-inch max, 13 spaces at 6-inch max. You know, these things here, these actually can be automatically placed by ProConcrete. So, you know, a lot of times you hear the sales pitch from Bentley and see how you just press a button and all these magical things happen and it does your plans and everything all automatically for you, and then you dive into the weeds and you know that's not quite true, and there's a lot of other stuff you have to do. This is actually one of the few cases where that is pretty close to the truth. I mean, ProConcrete can do some pretty impressive things for us. The full version of ProConcrete can do some pretty impressive things for us when it comes to the 2D plans production. And it also automatically creates can automatically create our reinforcing bar list for us. So this is another thing that is typically not very much fun to create. It's even less fun to QC this. So we can actually have the program create our bar list like this for us, and then if something changes in the main model, you know, the number of bars or bar length or whatever, then you just update the table and these numbers automatically update for you. So that's the stuff that's left out of the set of tools that are inside of OBM. But let's quickly go back in and talk more about what tools are in here. So in terms of just kind of a quick overview of the rebar modeling tools, I kind of break them up into 2 different workflows. There's this kind of this element-based dialogues that you can use here. Beam reinforcing, column reinforcement, pad footing, wall, slab. And now, one thing to keep in note, like a lot of different programs and software, ProConcrete was originally developed for the vertical buildings world. So when you click on something like beam reinforcement, the dialogue that it's going to bring up is going to look like something that you would expect for vertical buildings, because a beam to them is a beam that just goes across like a slab from column to column here. So these element-based tools here are not super useful for us for the most part. I mean, if you have a perfectly square or round column, you can use this, or a square, rectangular, element. You can use the beam reinforcing tool. But in general, I typically avoid these unless, again, the geometry is very simple, which is what those element-based dialog boxes were built for. Now, the second workflow for modeling rebar, which is what we'll use in the bridge roll, can kind of be broken up into 2 different categories of itself, kind of like an A and a B. And this is using the custom reinforcing tools here. Now, the custom reinforcing tools use guidelines to position the bars in 3D. And those guidelines can be manually drawn. That's kind of like workflow A. Or workflow B would be, they can be driven from the faces of the concrete. So you can do face-based rebar guidelines. So you can extract the concrete faces to produce the 2D guidelines that the custom reinforcement tools use. And that's typically the recommended workflow. Because that way, if the concrete ever changes, if this footing got taller or longer or wider, then those extracted faces move along with it, and then your rebar automatically updates and moves along with the concrete as well. So in the other case, where you're mainly drawing in the guidelines, in that footing concrete changes, or whatever your concrete element is that changes, the reinforcement does not automatically update. You actually have to extend or trim or move those guidelines to get the bars to move along with the concrete. So general recommended workflow is definitely this here in the face-based area. And then just to kind of give you a quick little preview of what this looks like in 3D, and start off with this wireframe view here. You can just kind of rotate around. It's kind of hard to obviously see what's going on here in this 3D view and wireframe here. But if I go on to a kind of a more rendered view, you can kind of come down in here and see the level of detail that we can really produce with these bars and the position of them. And the material property actually even has like that rib effect, so you can kind of really make it seem like it is the actual ribbed on areas on the rebar here. Come up and take a look at some of the Cap steel we have modeled in this particular case. And that's it for the overview on rebar modeling.